Yeah. Hello, all. Good evening. We'll wait for 5 more minutes and we'll start the session.
Okay, ma'am.
Yeah.
Okay, ma'am.
अपना फोन बहुत ना फोन उठावल ना कर फोन आई को
ना बात ना करो।
Yeah. Hello all. Am I audible?
Yes, ma'am.
Yes, ma'am.
Oh, yeah, sure. Okay. Good evening. So actually, this is solve with instructor session, no? So what we are trying to do is in this session, I will share the practice assignment question of week 8. Yeah. So I will give some time to solve. You can solve that. Yeah. So basically, these are very lengthy questions. So I am unable to make them as presentation. So just if your ID is also open, if your portal is also open, then you can just go to practice assignment questions of week 9 and try to solve them. Yeah, we'll discuss one by one. Okay. Yeah, please try solving first question of practice assignment 9.
Okay, ma'am.
Yeah.
Ma'am. Ma'am.
Yeah, everyone please try solving week 9 practice assignment question 1.
Ma'am, good evening, ma'am.
Yeah.
Ma'am, shall I ask one doubt, ma'am? It's a general doubt. Ma'am, what means while solving this pseudocodes, whether we need to check with our data or we need to solve generally, ma'am?
Generally only. Generally.
Generally, because I'm not going to write this one. I'm going to write qualifier exam, ma'am.
Mm.
I have a doubt whether we need to solve generally or whether they will give the table with the table.
No.
We need okay, okay, ma'am. Okay, ma'am. Thank you, ma'am.
Yeah. Okay. Yeah, you can let me know if solving is done. Yeah, anyone of you finished the solving?
Yes, ma'am.
Okay, yeah.
Yes, sir.
Yeah, okay. Just we'll wait for 1 more minute and one of you can explain. Yeah, anyone of you would you like to explain?
In the question number 1,
Yeah, yes.
can I?
Yeah, sure.
Okay. Can you show the code to me?
Yes.
Okay.
Yeah.
So the question says that considering the following graph generated from scores table, so our data set is scores data set. Each node in this graph corresponds to a student from the table. So each node, there is an edge between two nodes if the difference in the physics marks of the corresponding students is at most 5. So each node is the index number of that particular student, and there is an edge between those two nodes if the difference is at most 5. It can be 5 or it can be less than 5. The graph is represented by a matrix A. Sequence number is used to label the nodes in the graph, and the following pseudocode computes the matrix A. Select the correct code fragment to complete it. So we enter the line, read the line first from the pseudocode. Marks equals to read physics marks. So read physics marks is a function that gives me the dictionary with the index or the sequence number of that particular student as a key, and their physics marks as the value corresponding to that particular key. So I'll have a dictionary called marks, and we are moving to line number 2. N equal to length keys marks. So keys is a function that gives me all the key that gives me a list of the keys of a particular dictionary. In this case, the dictionary would be marks, and the keys would be the sequence numbers. So it will give me the list of all the sequence numbers. And length is another function that gives me the length of a particular list. the members in that particular list. So this would give me n the number of students in that particular data set. Now, moving to the next part, I have to fill the code. So if I take a look at the first option, A equals to create matrix n. Yeah, this part is correct because I'll have to first create a matrix and I have n students. So I will give I will pass the parameters n, and this will create a matrix with n rows and n columns for me, and each value will be initialized to 0 already in that particular matrix. Now moving to next line, for each I in keys marks. So marks was my dictionary, and keys was the sequence number. So for each sequence number and for each j in keys marks for another sequence number in that particular list, if the difference marks I minus marks j uh, is equal to 5, equal to minus 5, and is l- less than sorry, is, yeah, it is greater than minus 5 and less than 5. So it means that the range is minus 5 to 5, end terms included, endpoints included. So that is what was asked in the question, that the difference should be at most 5. It can be 5, it can be less than 5. So it will for it will assign a new value from that sequence number I to another sequence number j. It will assign the value I that will represent that there is a edge to between those two sequence numbers. So this option would be the correct option for this one question. And for the second option, if I take a look at it, why it's not correct, it says that the rest of the code is same. If situation is different, which says that it should be less than 5, but in question it was mentioned that at most 5. At most 5 means it can also take value 5, but here it will not take the value 5. So it will be strictly less than or strictly greater than minus 5. So it's not correct because of that. Option number C, why it's not correct? Because we have not created a matrix first. We have not created a matrix, so there is no point in checking the assigning a new value to that. And option number 4 is, if you take a look at it, here it says that 0, it should be greater than, but it we in the question it says that difference should be 5. When we talk about difference, it's the mod of that particular um, uh, subtraction, that mark subtraction is the mod. We take the mod, so it will also include minus 5 in this case, but here it is 0 only. So that's why option number A is correct for this question.
Yeah, okay, thanks. Yeah, is it clear for everyone, or do I need to explain any part? Everyone, please. Yeah, yes, please.
I have a question.
Yeah, your voice is very low. I'm actually unable to hear it properly. Can you be a bit louder?
Are you able to hear me now?
Yeah, yes, it's better now.
Yeah. Ma'am, my doubt is that, when there are n elements, it is creating a matrix size n.
Yes.
Yeah. So how does that matrix look like, ma'am? Now, will it have like, if there are 5 elements, there will be 5 rows and 5 columns, or how it is?
Yes, there will be 5 rows and 5 columns, n by n. Here in our data set, there will be 30 rows and 30 columns. So actually, so we need to
No,
indicate.
can you just take a data, ma'am? I mean, just say for the namesake, we can take just 5 data, 5 number data.
Okay, I will share my another screen. So matrix will be n by n. If I say A equal to create matrix, my matrix will be like 5 by 5, no? So it will be 0, 0, 0, 0. So this is first row. This is second row. This is third row. This is fourth row. Same thing. So fifth row also you will have the same thing. So this will happen, like create matrix will create the matrix n by n matrix, no? So there will be n rows and n columns. In our case, it is 5 by 5. So there are 5 rows, 1, 2, 3, 4, 5 rows and 5 columns. 1, 2, 3, 4, 5 columns. Okay.
Okay, ma'am. Yeah, but see, if I call the position 0, 0, where will it go, ma'am?
0, 0 is this position. 0th row, 0th column. 0, 1 means 0th row, first column. Okay.
Where is 0, 1, ma'am?
0, 1 is the second position here. This one. Wait. 0, 1 is this one. 0th row, first column. Okay, I will say what is, can you tell what is 2, 1?
Yeah, 2 would be the second row, first column.
Yeah, second row,
I mean,
first
second
column.
column. I mean, third row. Yeah, third row, first set. So 2, 1, right? Third row, second column. Yeah.
Yeah, that's what. So this is this element. So basically you have to count from 0, 1, 2, 3, 4. Okay, the indexing actually starts from 0.
Okay, ma'am.
Yeah.
0, 1. Okay.
Okay.
So
any
in
other
that iteration, it is the code, the first option, it is telling for every I and in the second, I mean, and in the next line, it is telling for every J. That means if I take the first position, I mean the first data in the keys and for iteration, and when I go to the next line, I will take that same value again, right?
Yes. Yeah. So there won't
Yeah.
be any connection. Actually, you are comparing both the same students. So actually,
Same
your
student, yeah.
yeah,
So
your diagonal elements will be 0.
Yeah, different. So that means that IJ position, suppose that student's position is 0. So 0, 0, it will be mapped to 1, right? In the matrix.
0, 0 will be mapped to 0. Initially, when you create a matrix, all the elements of your matrix will be 0 initially. When you say create
Exactly.
matrix, yeah.
Yeah, initially 0. Oh, but when, after checking the first mark, it will be the first position 0, 0. That will be 0, right? I mean, that will be 1, right? After we run the code. A of 0, 0.
Yeah, A of 0, 0 you are asking, no? So marks of I minus marks of J you will check. What is the difference? The difference will be 0 only.
0.
No difference.
Yeah.
Yeah.
That will be 1, right?
Yeah.
That position will be 1.
1. That will be 1.
Okay.
Yeah. So actually
okay, so
here,
if it comes like 1, do we get the desired result?
sorry?
Do we get the desired result because we are checking with the same student? Yeah, and we are updating the matrix as 1 for that student. So are we getting that result that we need?
Yeah, we can simply eliminate that also, because see, principal diagonal elements will be 0 initially, all zeros initially, but later you can say it will be updated to 1. Right? So
Yes,
yeah,
ma'am.
if you are comparing the same, you know, right? If you compare the same student with the same student, then only the principal diagonal elements you have to check. So you can simply ignore that. So the thing is, here they haven't mentioned like there is edge from I to J. Like if they specify there is edge from I to J, if the difference of the physics marks of the corresponding students is at most 5, at that time there is no need to do this minus at the time the answer will be 0 less than marks of I less than minus marks of J.
Yeah, that's what I thought. Okay.
Hmm. If
Okay.
they have mentioned specifically like there is H from I to J, that means I can mentor J or something like that. In that case, then at that time you have to only take the what not mod this, not absolute value. You have to take this only. This case at the time the correct answer will be 0 less than or equal to marks of I minus marks of J less than or equal to 5.
Yeah, exactly.
Yeah.
I got it.
Hello,
Yeah.
Because we
Yes.
don't need to look into that minus condition. Yeah.
Yeah.
excuse me, ma'am.
Yeah. Yes. Please.
What did you just say? I just missed out. I mean, I could not understand the logic. Can you repeat once again this if condition you were telling?
So the thing is here, what is the criterion to get an edge from I to J? Like there should be some edge from I to J, no? There
You are
means
saying basically there are two condition, a edge condition and other is at most 5 condition. That means we have to treat.
no, I'm telling here in the question it is given there is an edge between two nodes. That means between two students only, no?
Right,
Each
right,
node
right.
if the difference in the physics marks of the corresponding students is at most 5. At most 5.
That means less than equal to 5.
Yeah, that means less than or equal to 5.
The,
So
the,
it
the
should
range
not
would
be,
be the range would be
it should not be greater than 5.
fine,
Okay.
fine. The range would be from 0 to 5 or
Yeah,
from minus infinity to 5.
the range should be 0 to 5 only.
Done.
But
So
the thing,
in question in option number 1 and in option number 5, you were telling
yeah, in option number 1 is correct because it is not mentioned, no? There is edge from I to J or there is edge from J to I, it is not given. So there can be, so if the difference is minus 5, if the difference between IJ is minus 5, that means the marks of J is 5 marks more than marks of I, right?
right.
So in that case also there should be edge from J, that student, no? Like I to J. Because the difference between two students should be at most 5 to get
And
an
in
edge.
and
Yeah.
in option number 4, you were telling?
In option number 4, you can see, so only you will get, if it is like here it is 0, right?
Right.
0 less than or equal to marks.
5.
Yeah, in this option will be correct if they have mentioned specifically like there is edge from I to J, like I student to J student, if the difference between the physics marks is at most 5. Here they haven't mentioned from which, like where the
Okay,
from
okay.
where to where, like I to J or J to I, it is not given here. That's why we are taking minus 5 less than or equal to marks of 5.
Got it.
Yeah.
Got it. Thank you.
Okay, let's go to the next question. Yeah, please solve this and we'll discuss this. You can ask in between also if you face any difficulty in understanding the question. So actually this is lengthy question, no? Yeah, you can ask in between also if there is some difficulty. Has anyone finished solving question number 2? And yeah.
Yes, ma'am.
Okay, yeah. After 2, 3, 4, we can discuss. So yeah, if anyone has difficulty in solving while solving, please ask. Okay. Yeah, anyone finished all 3 questions? 2, 3, 4.
Done, ma'am.
Okay,
Can
yeah,
we
if
discuss this?
yeah, sure, we'll discuss this. Yeah, okay, we'll wait for 1 more minute and we'll discuss, like, let us also finish this. Yeah, anyone of you would you like to explain this question?
Can I?
Yeah, sure, yes.
So the question says, consider the following table containing the scores of n students. So we know we have n students in a class. Assume that all scores are between 0 to 100, 0 and 100. The scores in the first and last rows are shown as an example. The actual scores may be different. So refer only to the table's header to answer all questions. Okay. So this information is stored in a dictionary S. So there is a dictionary S with serial numbers as keys and corresponding scores as values. So S is a dictionary which has keys, serial numbers as keys and score as values. A graph G is generated from this table in the following manner. Given a pair of students IJ, uh, there is an edge from I to J if and only if I's score is strictly greater than that of J. So in the previous question, there was a difference between two students that was at most 5, but here it says that I score has to be strictly greater than that of J. Only then there is an edge. So this would be a directed edge. This graph is represented by a matrix A. Assume that the dictionary S has already been computed. So now study the following pseudocode. Okay, moving to the pseudocode, the first line is n equal to length of keys of S. So S is that dictionary, and the keys of it would be the sequence number of the students, and the length of that list would be the number of students, that is n. So we pass that number n to the variable A, and it creates a matrix with n number of rows and n number of columns, which with each value already assigned 0. So for each R in rows A, so for each row, we move to the columns. For each C in column, for first column, say, because columns and rows, these are sorted, sort keys dictionary. So this is already sorted. So if SR greater than SC. So if that student with sequence number in the rows is greater than that student in with the sequence number in columns, then we assign a new value to that. That is 1. We that means there is an edge between that student to that student. So if we take a reverse of it, suppose in rows we have C student, and in column we have R student. So C would not be greater than R. So we will not assign value 1. It will remain 0. So only one way we can assign 1. We cannot reverse that. So moving to the options for this. Uh, a row R of the matrix has 3 entries that are equal to 1, okay, and rest are 0. Which of the following statements about the student R is true? So in a particular row of this that matrix, it has 3 values that are 1 and rest are 0. So we can look at the options now. There are exactly 3 students who have scored more than a student R. No, it's not possible. If they've scored more than R, then the values would be 0 and not 1. There are at least 3 students who have scored less than student R. Uh, no, it should be exactly 3 students, because when it is strictly greater than. So when we say that some student has less than that particular student, only then we assign that particular value 1. So the option number C would be correct for this particular question. There are exactly 3 students who have scored less than student R.
Yeah, is that clear for everyone? The pseudo code and everything, explanation of the question. Any specific doubt regarding how your matrix will look like? Anyone? Yeah, please ask if you have any doubt.
Yes, ma'am. Yes, ma'am. I have
Yeah.
a question. I
Yeah,
have a
yeah.
doubt that how that matrix A will be represented here.
Okay. Let me stop this. Okay, let us imagine the same 5 by 5 matrix which we have taken earlier. So this is our first student. So actually what we are doing is like we will compare each student with every other student. So actually 0, 0 represents this element. So the first student is compared with that first student only because the same index for I and J we are getting 0, 0. So the marks is not greater than J, like I marks is not greater than J because the both indexes are same. That means the same student we are referring to. So the matrix, the element will be 0 itself. And in the second
ma'am.
case, yeah, in the second thing, that means the first students is compared with the like 0, 1 row. This is different student, two different students. So there will be edge if and only if this 0, 0th student marks is greater than the first student marks. That's all, no?
Yes,
That
ma'am.
means
Yeah.
0 sequence marks is.
No, my question is that in that position, will it store the mark or it will be 1?
It will be 1 or 0, either 1. The element of your matrix will be either 1 or 0 because when we
Oh,
create
okay. So
matrix,
the
yeah,
matrix cannot store any other value. Only
it
one will be.
can store any other value, but here we are making it as 1 and 0 only here in our question. Okay, it can store any other value. You can say a of ij equal to 5 or any other value you can put.
Okay.
Yeah, but here you're just updating it to 1 and 1 or 0 to indicate the edges between the two different student. If the marks is like in that range, if our student has greater than C student, that means 0 student has scored greater than first student, then we will update here to 1. Okay. Yeah,
Madam,
that
one
means
question
And,
is that why it is less, why it is not 3 more? The option was one was 3 more, one was 3 less. Why not 3?
exactly 3 or less than. See, the question is about what is your doubt
My
here?
doubt was
Mm.
saying that it is why it is less, why not more? It is saying that 3
So-
students who have scored less or 3 students who have scored more.
More, yeah. So you can see what is the condition to draw an edge. You can see
So it
there
is
is,
from I to J, that is from R to S.
yeah, there is an
R
edge
to C,
here,
R to C.
to see if and only if I score is strictly greater than that of J.
Hmm.
That means how edge is indicated here? Edge is indicated by 1, right?
Right.
Yeah. So here it is telling a row of the matrix has 3 entries that are equal to 1 and the rest are 0. That means our student must have scored greater than greater marks, more marks than 3 students, right? That's why then only we can get edge from R to C. At that time only we will get ones, right?
Okay. So in this case, the option would have been there are exactly 3 students.
Yes.
The first option who have scored more than C.
Who have scored less than
Less than C.
See, the correct answer is there is edge from R to C. Here, how it is indicated, ARC is equal to 1, no?
1,
That
right.
means R has scored more marks than C. Here you
Right.
can see the condition is also S of R greater than S of C.
Of C, right.
Yeah. Here you can see a row R of the matrix has 3 entries that are equal to 1. That means R has scored more than R has scored more than more marks, right? R has scored marks. So there are exactly 3 students who have scored less than R. R has scored more marks.
Right. Okay.
Yeah.
That's yeah. Confusing.
Ma'am,
Is it-
2 more questions.
Yeah,
Hello?
yes, please. Yeah, yes, please.
Ma'am, here in the first line of iteration, it is going for each R in rows A.
Hmm.
Yeah, that means we are going to for each row in the sense it is going to the 0th row in the rows
See,
A, right?
how iteration will happen, I will tell. So first 0th row is fixed. That means 0th row is fixed. For that 0th row, we will iterate through each and every column. So the element will be the first row will be iterated 0, 0, 0, 1, 0, 0, 2, 0, 3,
Yeah.
0, 4, so on. And then this for each scene columns also completed, right? Because each row.
Completed, ma'am.
Yeah.
And
Yeah.
see, it is telling S of R. That means S is a dictionary, right?
Yeah, S of R, that means some key only,
S of
right?
0, what is it, ma'am? How can we go to the 0th position in the dictionary?
What is S? S is a dictionary. The
ma'am.
information is stored in dictionary with serial number as keys and corresponding scores as values. So S
Yeah.
of R will be some score. R
Yes,
is some
ma'am.
sequence number. So S of 0 will be some marks of that 0th sequence number student. S of 1 will be
Okay.
marks of, yeah.
So that means the 0th row in the sense 0, 0 position in the sense that is the serial number of that student, first student.
So in our matrix, it is 0, 0. The serial number of student will be either 0, 1, 2, or 3. That numbers only, no? So basically, in the dictionary, we are checking what is the marks of the 0th student or first student or anything. Okay. If they have that marks, greater marks, then we will simply draw edge from R to C in our matrix.
Ma'am, another question. There is age from S to R. So basically, sorry, R to S. And instead of this, putting this matrix n by n matrix as 1, 1, 1, and 0, 0, 0. Instead of this 1, can I mention exactly the difference between the ith row and jth column? For example, ith row and jth column, there is a person sequence number, say 1, 2, 3. There is a person sequence number 4, 5, 6, and there is a difference between their marks is a 10. So instead of 1, can this matrix show 10?
Yeah, you can show any value, but you should show some connection between student I to J. How will you know whether I has scored greater marks than J? There should be some indication, right? Somehow you should indicate that I has scored greater than marks than J. So in that case, you can just write the difference also. If they are positive numbers, if the difference is positive numbers, then that particular student has scored that more marks than that.
I'll put, since the age is from I to J, I'll put positive values as the age and the negative values as the opposite of age. Means there is trailing behind that person, that student. I can do that, na?
Yeah, you can do that with any value. If you say positive values as edge, so
yes, positive value as edge. So if it is 10 instead of 1, it is 10. Basically, then I have scored 10 above J. And if it is minus 10, that means I had scored 10 more than J.
Yeah. Yes.
Okay.
Yeah, you can.
That's a clarification I wanted.
Yeah, yeah. But basically, we are indicating most of the questions.
Mostly out of 3, 1, and 1. So
Yeah,
it's
1 and
basically
0.
we are basically creating almost a unit matrix type of thing.
Yes, yes. So if it is 1, then there is connection between R and C. R and C, that means the R has scored more marks than C.
And just another question, like if I inverse the matrix, like in any matrix, we can also inverse it. In that case, this matrix also can be inverted.
Inverse the matrix means?
Means any matrix, n into n matrix.
Yeah,
I
that
can also...
is, yeah, you can, the matrix you can inverse, but the thing is the relationship. what relation you will get by inversing a matrix?
That's what I'm
Because
saying. What is the physical? I'm saying just
yeah, that's what I'm asking.
algebraically, a matrix can be inverted. So by physically, what does it have any significance or meaning?
Yeah,
If I
here
invert a matrix?
does see inverse means some formula you have, no, that significance here it won't carry here. But if you tell like if it is -1, that means no edge. 1 means if it edge. If you inverse that, yeah, then inverse means if you make it as positive instead of positive, if you make it as negative, that inverse we can do. But if you say the formula inverse, whatever formula that is there, if you yeah, that does not have any physical meaning here. Inverting, yeah.
Okay. Thank you, madam.
Yeah, the inverse, the definition of inverse should be properly defined. Inverting, yeah. What does inverting means here? Yeah. Okay, the second question, is it clear for everyone or no?
It's clear, ma'am.
Yeah, okay. We can move to third question. If R, C are two students with unequal scores, it is mentioned here clearly R and C are two students with unequal scores, then which of the following statements are true? If ARC is 1, then ACR is also 1. That is not possible, no? If R has scored greater than C, that means C should have scored less than R. So it should be 0. So that's why this is wrong. The second option is correct, because if ARC is 1, then ACR is 0. 0, that you can say definitely, because both students are unequal scores. If R has scored greater than C, that means C must have scored less than R. It is given that they have unequal scores. If ARC is 0, then ACR is 1. That is also correct. If ARC is 1, then there is insufficient information. That is not correct. We can definitely tell, right, the relation, because we know if R has scored greater than C, then the C must have scored less than R, given they have scored unequal scores. Is it clear?
Yes, ma'am.
Okay, we'll move to fourth question. Which of the following statements about the matrix A are true? It is a multiple select question. Okay, there is at least one row that has only ones in it. Let us take the case about the student who has scored highest marks and the student who has scored the least marks. Okay. For the student who has scored the least marks, then he won't, the condition won't be satisfied.
His row will be zeros, all zeros.
All zeros only he will get. If this condition won't be satisfied, so for that student, for that row, you will get all zeros only. Okay, for the student who has scored the maximum marks, so will it be all ones for him? No, right? No, there will be, because you will compare that R student with the R student, because 0, 0 will be compared. In that case, S of 0 is greater than S of 0. That won't happen, because you are checking the same student with the same student. So that won't happen. So in that case, you will get 0. And the remaining all ones you will get 0, 1 for 0, 1 student and 1, 0 second student. You will get all ones. But for this, but for the same student, that means S of 0, 0, A of 0, 0, in that case, you will get 0. So for the highest mark student also, it won't happen. So all ones won't happen. There will be 1, 0, like as its element. Okay, anyone of you, would you like to answer this question? The fourth question.
Then there will be at least one row which will have only zeros in it. That would correspond to the student that will have least marks, because if we compare that student's marks to every column, it will have lower marks. So we won't update any of the values to 1. So whole row will be 0 for that particular student, which will have lowest marks. And for the particular student who has highest marks, his whole column will be zeros, because whichever student we compare him to, the student will have lower marks than him. So we won't update the that particular column to one value. So his whole column will be 0. But his row, if you look at it, it will have 1 0 when we compare him to himself.
Yes.
So it will not be all ones. So the option number B and option number uh, D. B and D would be correct.
Okay, is it clear for everyone? Is it clear for everyone or not? Should we take some example and try it out? Anyone of you, could you respond?
Clear, ma'am.
Yeah, ma'am, we can go.
Yes, ma'am, it's clear.
Okay. Okay,
Clear.
please solve. Yeah, please solve this 5 to 8 questions then. Yeah, if it is finished, you can tell me.
Done, ma'am.
Okay. Should I wait for some more time? Any others? Or should we
Just
proceed?
a few more minutes.
Yeah, okay, sure.
One or two.
Yeah, sure. Meeting undate. Yeah, is it done or not?
Yes, ma'am.
Yeah. Anyone of you who has solved it correctly, would you like to explain?
Can I try now?
Yeah, sure. Yes, please.
Uh,
Yes.
yeah. So continuing with the previous question, assume that the matrix A has been computed, study the following pseudocode. So in the previous question, we created matrix A, which was representing a graph from students. And if a student's marks was strictly greater than the other student's marks, there was a directed edge from that student to another student. So we take that matrix A. Now moving to the pseudocode, n equal to length of keys of S. So S was the dictionary where each particular index or sequence number was was the key, and the value was the particular marks of that student. So we take the length of that keys, that would give us the length, the number of students, and we initialize a variable called k to 0. Some score is another variable which keeps a track of that particular student's marks. So k would be some index number, and it would reference the dictionary S and get us back that particular student's marks. So that would be some score. Now we have another variable called walk. Walk would be we have initialized it to true, and another variable called hops. Hops is initialized to 0. Sorry. Now entering the while loop, we while walk. This means that while walk is true, so initially walk is true. So we enter the while loop, and we see that we have initialized walk to false. So walk is reinitialized to false, and to next line 8, for each C in columns of A. Now, A is our matrix, and for each column C, if A, K, C, so initially our K is 0, because we initialize it to 0. So for 0th row, we check each column for that row, and if any of that for that row, if any of the column has value 1 associated with that, then only then we move to the next part. That is, we initialize that k to that particular column's index number, and that sum score, we update the sum score. We go back to the dictionary s, and we take out the marks for that particular student, and that is our sum score. And we reinitialize walk to true, and hops would be incremented. Hops would be hops plus 1. Hops was initially 0, so it will become 0 plus 1, and we exit loop. So exit loop will for if we execute exit loop, we will exit that for each loop. So we will exit that for each loop, and we will go down, and again while if walk is true, then we again do that. So if suppose my 0th row has the minimum marks in it. So in previous questions, we remember that if some student has minimum marks, his whole row would be 0. So if suppose my first row is my minimum marks, then walk would be false for each column A in columns of A. If 0 and particular column equal to 1, it will be false. So it will not execute this whole if conditions, if loop, and it will just come out. And my values would be hops would be 0, and walk would be false. So k would be the student with minimum marks. And suppose if we have to if the student with the minimum marks was in the third row. So if the student with minimum marks is in the third row, and we go through the first row, there will be someone, and whenever we see that one in the 0th row, we will update k to that particular column's index number, and some score would be updated to that particular column number, and walk would be again reinitialized to true, hops would be 1, and we again go to the second row. Similarly, we'll go to the second row, and similarly, the moment when we enter the third row with the row with the student with minimum marks, walk would be false, and we won't execute this if loop. So k would be the again k would be the index number or the sequence number of the student with minimum marks, and some score would be containing the score of that particular student, and walk would be false because we haven't reinitialized to true, and hops would be 0 to 1 was 1 hop, 1 to 2 was 2 hop, and 2 to 3 was 3 hops. And we won't again increment hop because we will exit the loop. We will not be able to again execute the while loop because our walk will be false. So we will execute this whole, we will exit this whole pseudocode. So moving to the question, answer the following 4 questions after executing the pseudocode given above. The values of all variables mentioned in the following questions represent the state of the variables at the end of the execution of the above pseudocode. All 4 questions given below are independent of each other. Okay. Moving to the question number 5. Which of the following statements about the variable sum scores is true, irrespective of the contents of the score table? So it is equal to the score of student 0. No, it won't be equal to the score of student 0 unless unless that student has the minimum marks associated with it. So I don't think this should be the answer. It is equal to the score of student n-1. Again, same logic. Until and unless that n-1 student has the minimum scores, we cannot say this for certain. Moving to the third option, it is the minimum score in the table. Yes, it is the minimum score in the table. It is not the maximum score in the table because whenever we face a student with the minimum scores, his whole row would be 0, and we won't be able to execute that pseudocode further. So the answer would be it is the minimum score in the table. Moving to the question number 6, the values of hops is equal to 0. Okay. Which of the following statements are true? It is multiple select questions. Okay. So only under one condition hops would be 0. Only when the student with minimum marks is the row 0 is represented by row 0. Only then we will have hops 0. Other than that, if we have that particular student in say row number 1, then we hope hops will be 1. If that student is present in row number 3, then hops would be 3. So if it is given that hops is equal to 0, that means that that particular student with minimum marks is present in the row 0th row. So student K has scored the maximum marks. No, it has scored the minimum marks. So second option is true. Student K has scored the minimum marks. The third option, the value of K is equal to 0. The value of K, yes, the value of K would be equal to 0 because that would be the sequence number of that particular student. So these two would be the correct answers for this one. Moving to question number 7, the variable hops satisfies which of the following inequalities? Okay, particular one, 0 equal to greater than hops can be equal to 0 and greater than it. Yes, it can be, but less than n by 2. No, that is not. That would not be correct to say, because if suppose the minimum mark student is in the last line, we cannot say that it is n by 2. For the same logic, the second one also will be incorrect. 0 to if it is greater than 0, it can be greater than 0. If it is equal to 0, yes, it can be equal to 0 in case it's the first line, first row. And n minus 1, yes, this would be the correct answer, n minus 1, because we have n students, and since we are starting each row with 0, so we'll have 0 to n minus 1 rows. So the minimum mark student can be at the 0th row or n minus 1 row, and hops would be equal to that quantity. So the third option would be correct for this one. Which of the following statements are true? After executing the pseudocode given below, it is multiple select question. Entering the pseudocode, line number 1, sum equals to 0. There's a variable called sum. We have initialized it to 0. Moving to the second line, for each C in columns A. So we will check that the particular column, and sum equal to sum plus A KC. So K is the student with minimum marks, and if we take the sum of each value associated with its columns, they all will be 0. The whole row is 0, so the sum is equal to 0. So the first option is correct. Sum is equal to n minus 1 is incorrect. Sum is the in degree of the node K in the big graph. No, so in the previous pseudocode, it was mentioned that the only when the student K has the marks greater than C, only then there would be an edge from K to C. So it is the out degree of node K. Since all the out degrees of this node particular K are 0, the sum is also 0. So sum is the out degree of node K in the graph. So the particular for this particular question, option A and option D would be the correct options.
Yeah, okay. Thank you. So any other doubts for anyone? Anyone of you, any other question, any questions?
So what was the out degree? I missed it.
And ma'am, also can you please explain how sum is equals to 0?
Sum is equal to 0.
Oh, yes. I didn't get that.
Okay.
Ma'am, also that exit loop function, how will that exit from that while loop, or from which loop it is exiting?
For loop, it will exit from the for loop. Yeah, I will take this question first. Why sum is 0? Right? What is the value? You can see K is the marks of minimum marks, right? It is the minimum marks. So that
Yes.
is the student has scored the least marks. So, okay, will
So
that
K is
student
actually the row number which has the least marks.
least
Mm.
marks student.
But
Mm.
but like I was confused because in the 8th question it is not mentioned anywhere that it's representing the previous question. I thought it's like general.
No, it is like 5 to 8. You can see there's this all questions. 5 to 8 questions 5 to 8. All questions are related to this only.
No, to this, yes, it is related, but then okay.
Continuing with the previous question and assume that matrix A has been computed. Okay, so it is the minimum marks student. So minimum marks student won't get edge with any other one, no? So AKC will be 0 for every value of K. The particular row will hold zeros only, the kth row, because he has scored the least marks. So that's why your sum value won't be updated to any other value. Is it clear?
I have a doubt
Yes,
actually
ma'am.
in the this one. Like, why are we considering minimum value and not the maximum value?
Why? Because what is the value of K? You can see K is
That's what the AK for K. Why we are considering the minimum value?
because K is actually from our pseudocode. K is
Okay.
actually the index of the least marks student. K is a sequence number of the student who has scored the least marks. From this pseudocode, you can see. Because we are checking whether if AKC equal to 1, that means for every value of row, the case we are starting with 0 and we are just, these are simple just variables, we're just iterating over the columns. For the particular 0th row, we are iterating each and every column and we are checking if AKC equal to 1, that means if this K 0th row student has scored greater than any other student in that particular column, like if he has scored greater than any other particular student, then it will be updated to, the value will be 1. If not, the value won't be 1 and the statements won't be executed. Let us take like the 0th student, row student has scored greater than the other students. So in that case, then the K equal to C will happen. That means here you can see there is edge from R to C. From the previous question, there is edge from R to C if R has scored greater than C. There is edge from R to C, like ARC equal to 1 if R has scored greater than C. If AKC equal to 1, that means K has scored greater than C. That K student has scored greater than C. Okay, whenever we have found that particular student, then we are updating our K value to C and sum score equal to S of K. We are updating the sum score also to S of K and walk we are making true just to continue this iteration, and hopes equal to hopes plus 1 we are doing. Then we are just exiting the loop. Hops we are increasing and then we are exiting the loop. This will happen for each and every thing.
Okay.
But K value is updated to C. That means what is our C according to here? C has scored less marks than K, right? We can see there
Yeah.
is edge from R to C if and only if R has scored greater than marks than C. So C has scored less marks than K. So similarly, we will check now our new K is C. Again, for that C value, for that this new K value, new K, let us take it as 2 or something. We will check with each and every column and similarly we will update. By doing this procedure, finally we will end up by storing K as the index of the student who has scored the minimum marks. Okay.
Okay, got it. Thank you.
Yeah, any other doubts?
So what was that out degree? I could not follow.
Out degree. So actually you can see in the first question itself, there is edge from I to J if I score is strictly greater than j. That means we are drawing edge from I to j. That is out degree of I node only, right? We are drawing edge from I to j. That means edge we are drawing from I to j. So that is directed and it is from I to j. I node to j node. So is it out degree to I or is it in degree? We are drawing out away from I, know we are drawing I to j. So that is out degree for that I. So the thing is here, what is the thing here? Sum is the out degree of node k in the graph, because sum equal to sum plus we are counting the number of edges from k to c. Is it out degree to k or is it in degree? It is out degree, right? We will get AKC will be 1 only if there is edge from K to C. That means if we draw edge from K to C, we are drawing edge from K to C. That means it is outer edge, out degree only. If we draw from C to K, that means it will be in degree to K. Is it not clear or clear?
Maybe I need to. I did not complete watching all the videos. Probably I missed something.
Yeah, if we say if there is edge from I to J, that means we are drawing one arrow from ith node to jth node. One drawing I to J. That means it is just, I will draw. If I say I to J, if there is edge, that means, yeah, I'm drawing edge from I to J, means I'm drawing outer.
Okay. Are you actually drawing, ma'am? I cannot see.
Oh, sorry. Yeah. So if there is edge from I to J, that means we are drawing edge from ith node to jth node. That means it's out degree. If I say there is edge from J to I, if there is edge from J to I, then that means we are drawing from J to I. So that is in degree to I. But here you can see in our question there is edge from R to C if R has code greater than C. That will become out degree.
In degree means a reverse path, is it?
Yeah, in degree means, yeah, it's reverse path. That means it should come to I.
Okay.
Out degree means it is moving away from I.
Okay.
Yeah. Any other confusion in this question? 5 to 8 questions for any one of you. Okay, if it is clear, let's move to the other question 9 to 10. Yeah, anyone of you, is it done? Should I wait for a few more minutes, everyone?
Done, ma'am.
Yeah, is it done for everyone? Should I wait for a few more minutes? Others? Yeah, I think we can continue. Anyone of you, would you like to explain this question? Anyone?
Can I?
Yeah, sure, yes, please.
Sure. So the question says, consider the graph G that we worked within the previous two problems. Graph GR is a graph that is obtained in the following manner. We are creating a new graph. Given a pair of students IJ, there is an edge from I to J if and only if I scores is strictly less than that of J. B is a matrix that represents GR. GR is the second graph. Uh, okay. So moving to the question,
Yeah,
by the looks
G.
of
Yeah, sorry, yes, please.
Initially it looked to me that GR would be the inverse of G, but it is not true. There's a slight difference in that GR and G, which we'll discuss in the next ninth and 10th questions. So moving to the text 9th question, the following pseudocode is used to construct the matrix B from A. Assume that A has already been computed. Select the correct code fragment to complete the pseudocode. It is multiple select question. Okay. We are making new matrix B from A, and B represents the new graph GR, where a student will have a directed edge to another student only if that student's marks is less than the another student, strictly less than the another student. Okay, so moving to the pseudocode, line number 1, we have initialized a variable called n, and n is length of keys of A. So our A was the matrix and its keys, and we take its length. So it will give us the number of students, and B equal to create matrix n. So we'll create a matrix with n rows and n columns, B, with each value initialized to 0. Moving to line number 3, for each I in rows of A. So for every row in that particular matrix A, for each J in columns A, for every column of that particular row, we do something. We are going to fill the code. Okay. Moving to the options, if we take a look at it, the Bij equal to Aji. So Bij means that there is an Bij, suppose there is a directed edge from I to J. That means I's score is strictly less than J. If I's score is strictly less than J in B matrix, it will represent 1. And Aj in matrix A, there would be a directed edge from J to I, since J would be strictly greater than I. So first option would be correct, because if there is a directed edge from I to J in matrix B, there would also be a directed edge in matrix A from J to I, because if I is less than J, J would certainly be greater than I. So there would be a directed edge. But in case both are equal, so if Bij, I and J are equal, value for Bij here would be 0, and in matrix A would also be 0. So that is why it's not exactly the inverse. B matrix is not exactly the inverse of A. So this would option 1 would be correct. And moving to option number 2, Bji equal to Aij. Yes, this would be also correct. It is same with the similar to option number A. It's the same thing. Moving to option number 3, if Aij equal to 0, Bij equal to 1. No, that is incorrect because there can be two possibilities for Aij to be 0. Either I is less than j, that is why it's 0, or I is equal to j, that is why it's 0. So saying that I is strictly greater than strictly less than j, that is incorrect. So that wouldn't be correct. And moving to the fourth option, if a ji is equal to 1, that means that j's marks are strictly greater than I. That would mean that i's marks would be strictly less than j. Yes, this is correct. If j's marks are strictly greater than I, then i's would be strictly less than j. Moving to the fifth option, Bij equal to 1 minus Aij. No, this is not correct because in case I and J has similar marks, then they won't be strictly greater than or strictly less than. In both cases, the value would be 0. But here it will give us 1 for matrix B. So only uh, option number D and AB. A, B, and D would be correct for this question.
Yeah, is it clear for everyone or any specific doubts you have? Any one of you?
No, ma'am, it's clear.
Yeah, okay. Yeah, you can just have a look through these questions or any other questions. Just we have time now, we can take few more questions. Just take some time, like 5 minutes or something, and see all the questions from the practice assignment 9. And then if you don't have any doubts, we'll take the other questions. Yeah, anyone of you any doubts from this practice assignment? Yeah, if not, you can ask any other doubts also.
Hello.
Yeah, yes.
Hello, Madam Abhinav this side. From previous week, I would like to ask two questions. Can you
Yes.
go to graded assignment 5, GA5? Question number 9 and 10. I could not able to understand those. Can you help me to understand the code
Yeah,
itself?
yes, please. Yeah, yes. Yeah, you can explain where it is not clear for you.
I could not able to understand the code basically.
Yeah, with this code. Okay.
See, the question statement
Mm.
says let A and B be positive integers. That means I can take anything. These are not list as per, as per my thought, my understanding.
Yeah, A and B are positive
So
numbers.
I can take randomly any two integers, positive integers basically.
Yeah, you can basically take anything.
I have taken. Then procedure reminder A and B returns if A is divided by B. Fine. Procedure B do something. Then this X is the basically that card.
Yes, X is a card.
Card of scores data set. I can say that. Or
Yeah,
no?
X is a card. Just X is a card. You can just check the what is.
No, these are independent questions. They are not related to any other.
Okay. X is a card then.
Okay,
9,
done.
10.
Then the next line says that can you just scroll up? Scroll down. Can you? I couldn't see that.
Okay, this one here.
This one. Yes.
Yeah.
So it says J is equal to 2. It's a variable. Flag is equal to 2, right?
Yeah, J is variable. It's just
J
a
is variable. Flag is equal to 2. And
true.
if X is equal to 1, return false. So A and B are two positive integers. J is equal to 2. I could not able to relate those things up.
Sorry, I didn't get it. J equal to true.
Are you getting
J
my
equal-
voice clearly?
Yeah, yes,
am
yes,
I
yes.
able to communicate?
Yeah.
Okay, fine. The point is A and B are two positive integers. J is equal to 2. Flag is true. If X is equal to 1, return false. I could not able to understand the code basically this time.
So here X is some, you can see X, we are telling if X equal to 1, no? That means X is some number. It's
Okay,
not
I can
some
take
card.
any number.
Yeah, it's
Here,
a
if
number.
randomly I can choose any number.
Yes, randomly. So you can see what is, when will the procedure do something of X return true? The question is that one, no? So we
yes.
have to check when this procedure, actually what this procedure is returning, it is returning flag.
Right.
So we have to check when the flag will be true.
Right.
Okay, so you can check the case if X is a prime number. You just keep by X as a prime number, X as a even number, X as a odd number, and X is more than 1. Like keep such values and check. Or else what you can do is just execute the pseudocode and see when this is returning true. So you can see if X equal to 1, it is returning false, right? The code is returning false. While J less than X, that means X value is something, J less than X, the 2 is less than X. So J value is something greater than 2. If the remainder of X comma J equal to 0, that means, okay, let us take X as 3. If 3 comma 2 remainder is 0, it is not 0, right? It is like 1. So
right.
at the time what you have to do is J equal to J plus 1 you have to do, and yeah, J equal to J plus 1 you have to do.
And
so final,
I have to check for another value, let's say 4.
No, J equal to J plus 1 we will do.
Okay,
That
3 ho
means
jayega.
3.
Okay, done.
3
Got
is
it.
not less than 3. So this condition is false. This while loop has become false. Return flag you will return. So what it is returning? It is actually returning true only, because flag we have not updated to false or something. Because flag we have not updated.
Done.
It is initially.
That means I need to vary X according to options. I can
Yeah,
take randomly any value.
Yeah, randomly it's prime number. You can check for take a prime number. You can check an even number. You can check an odd number. You can see we have checked for some.
Okay,
like you can,
I got your point.
Yeah.
Then can you throw some light in question number 10? They are
Okay.
both related.
Yeah, sure. Consider the procedure discussed above. What will be the value of M at the end of execution of the given pseudocode given below?
So here the thing I would like to clarify, this position is equal to 1. That means the list, the item number 6 will be 1. Its position would be 1, and the next item element 10, its position would be 2, and so on. Is my understanding correct?
No, position is just basically something like variable I equal to 1. What is your
It
doubt?
is not an index.
It position is in, see here, you can see position is some variable. It is not
Okay.
index. It's some variable like I equal to 1, j equal to 2, something like that
Okay,
only.
done.
Yeah, do something of position. The some here do something of x we have done no previously.
Yes.
Same, do something of position. Some number only we are passing. You can
Okay.
see position is initially 1. Later you can see after iterating you can see it is 2.
Okay.
Yeah, it is 3 because we are calling do something of position, no, for every
Okay.
position.
Okay.
Yeah,
Okay.
yeah, yeah. And for each element also you are calling the do something procedure, calling do something procedure. And just you are appending the elements to your new matrix. If this condition, if the do something is actually written, say the true or false. If both the do something of the position and do something of the element, if it is returning true, then you will add that element to either this element to this m. Okay, that means
Right.
adding means you will update appending your list. Yeah.
Right.
Okay, you
Okay.
can basically, you can see from the answer, if x is a prime number, this value is returning true, no? So basically you can check, do something of the position should be prime. That means for the second element, that and the number also should be prime number, right?
Right.
Prime number element
Right.
also should be prime. So element should be prime. When the element should be will be prime for 2, 3, 5. What are the indexes here? 0, 1, 2, 3, that only no indexes here of your list. So for the position means for the prime index and for the prime element, the procedure do something will return true because there is and condition in between. So yeah, for the prime index means 2, 3, 5 are prime indexes and the element also should be prime. At the second index you can see the element is 11. So that element you can append 2, 3, 5. So you can just basically check. You can basically check at the position and this element, and you can just check for this condition. If the condition is becoming true, then you can just append your list. That's all.
Okay.
Is it clear or not? If you have some doubts,
Yes.
you can
No,
ask.
no, it's fine. Thank you.
Yeah, yeah. Okay. Any other doubts for anyone? Yeah, any other doubts for anyone? Any from any other weeks or anything?
Any other revision session will be there, ma'am, in this week for the week 5 to 8 or something.
I think mostly revision session won't be there because yeah, Deepak has already told, like he has covered the concepts in the previous weeks about list and dictionary. So mostly it won't be there.
Mock
In the
test will
next,
be there, no, ma'am, by
yeah,
this
mock
Friday.
test will be there. Mock test will be there, and mock test questions will be discussed also, I think mostly. With just 5 more minutes we have. If you have any doubts, please ask.
How to prepare for this graphs and matrix, ma'am? We should try to draw every matrix and its graph so that we easily follow the pseudocode.
That won't be the case. Just understand the iteration. So we will compare iterate like for each R in A, for each C in columns of A that we are doing, no? So you need to get idea like how we are iterating over the maps. Just you need to
Yes.
get idea. Drawing and everything, I think that won't be much helpful, but just get idea. 0 0 means represents what, 0 1 represents what. So that means 0 at the student we are comparing with first student. So and also check like ij indexes we are checking, every time we're checking for some condition. So I think basically you have to understand the iteration. So if I say how we are iterating over the elements and which condition we are checking and how we are drawing edges, that's all. Drawing matrix won't be that helpful, matrix or graph. Understand that whatever we are iterating. So yeah, if I
Hello?
say yes.
Can we discuss activity 9.6, question number 3?
9.6 question number 3. Consider the below sentence. The sequences, numbers and parts of speech of each word are written next to them, the red color by comma. Okay. The sequence number and parts of speech of each word are written next to them in red color separated by comma, that we are not doing, and represents noun. Actually this is 0 is sequence number and n is the parts of speech. That means it is noun for the word, that particular word. Choose the correct.
These sequence number are nodes, right? These
Yes.
are nodes.
Yes, yeah.
Okay.
Choose the correct connected graph between nouns and pronouns based on the concept explained in the lecture from the given output. So this is basically related to the concept that is explained from the lecture, directly from the lecture. So when actually you have to check when we are drawing edge between nodes and pronouns, you have to check. In the lecture you have to check when actually edge is drawn from noun and pronoun. Anyone have you remembered what is happening in the lecture? Did anyone of you remember what is happening in the lecture? When actually we are connecting.
Yes, the noun should be connected to the pronoun.
Okay, when we will connect noun and pronoun? Is there any condition to connect them?
The pronoun refers to the previous noun.
Okay, if it directly refers to the previous noun, or if how?
Then only we can have edge.
In a sentence, ma'am. In a sentence, nouns and pronouns are connected. That is the condition. In one sentence.
Not just nouns and pronouns. Nouns and nouns as well are connected with a verb between them.
Yeah, that is a word. Connecting the noun with the pronoun is a verb, but in a sentence.
So, in this case, ma'am, payasam is a sweet Indian. So this Indian is connected to payasam via is. Dish is also connected to payasam, which is prepared from boiling. What's the next? Milk. So milk would be connected to dish. Payasam. Milk would be connected to payasam.
So what about which is connected to?
We're not taking into account pronouns in this case.
Okay, we are not taking account to pronouns here. The graph between nouns and pronouns here it is mentioned, no? So actually, which is some
okay.
6. No,
So,
6 is there in our graph.
6 would also be connected to
Zero
the
and one.
Python. Yeah, 0, 0, 0.
A 0 and
Via
okay,
1.
0.
Yeah.
Okay. So actually what you have to do is, here in this case, you have to connect. Okay, there are some sequence numbers, and yeah, you have to check between this noun, between these nouns, whether there is a verb. If there is a verb, then that is connected. So payasam, between payasam and what Indian, there is verb is. So payasam and Indian is connected, and
Right.
Indian and dish are not connected because there is no verb between them.
Right.
Yeah, that's the case. And which is connected to payasam, because between which and payasam there is, which is not connected to dish and Indian because nothing between them, no pronoun, no
Right.
verb. Yeah, that's all condition we have
No,
to check.
I got
and-
the gist. I'll do that. I
yeah,
got the gist.
yeah, okay.
Thank you.
Yeah, any other doubts?
Multiple choice questions, lot of confusing options are given, man. Sorting out those in a quick time will be.
Yeah, so for partial marking you will get, but if you choose one incorrect answer, no, you won't get any marks.
Yes, that's happening on the previous
Yeah,
quiz.
so you should be careful. You just choose only the mostly confident options, because if you make at least one option as wrong option, if you select one wrong option, then and the question will be gone, no. So if you even just select most confident option, then you will get some partial marks also as well. If two options are correct, you will get 0.5 marks. Like if it is 1 mark question, if it is 2 marks, then you will get 1 mark. So yeah, most confident options you have to choose.
Right.
Yeah, any other doubts?
No, ma'am. Thank you.
Yeah, okay. So if no one are having doubts, then we can just end this session.
Thank you, ma'am.
Yeah, thank you.
Thank you.
Yeah, thanks.
Thank you, ma'am.
Thank you.